The last piece of information we need before calibrating is revolution time, the time necessary for the pivot to complete one full revolution. You'll use this as the basis for determining the injection rate. Calculating the revolution time is a two-step process. First, we must determine the circumference of the last wheel track. The formula for calculating circumference is 2 times pi times the radius. For this example, we will assume that the radius, or distance from pivot point to the last wheel track, is 1,250 feet. Circumference then equals 2 times 3.14 times 1,250 feet. We determine the circumference of the last wheel track to be 7,850 feet. Travel speed of any moving system, pivot, or linear must be measured accurately. When measuring travel speed, the system should be running wet at the speed and pressure that will be used while chemigating. If the system speed is changed in any way, recalibrate. Avoid determining pivot speed at one percentage setting and mathematically calculating the pivot speeds for other settings. A number of factors are involved, but this approach can introduce significant errors in travel speed. Travel speed is expressed in terms of distance and time. The measurements can be recorded in two ways. 1. Record the time necessary for the outer pivot tower to travel a pre-measured distance, usually a minimum of 50 feet. 2. Measure the distance traveled by the outer pivot tower in a pre-selected time, ordinarily a minimum of 10 minutes. The end result of either method is travel speed expressed in feet per minute. Remember, a measurement error of only a few feet or a few minutes can result in significant error in the calibration process. If your field is hilly or rolling, check rotational speed at several locations in the field and use the average speed. Soil type, slope, soil compaction, and track depth are among the factors that can affect travel speed. For discussion purposes, we will assume travel speed of the last tower has been measured as 6.8 feet per minute at a percentage timer setting of 100%. We next divide the circumference, 7,850 feet, by the travel speed, 6.8 feet per minute, and determine that the pivot will complete one full revolution in 1,154 minutes. To convert that revolution time to hours, simply divide the number of minutes needed, 1,154, by 60, the number of minutes in an hour. The time needed to complete one revolution is 19.2 hours, or 19 hours and 12 minutes.